Jai Hind all of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering at Akgec Engineering College. So, students, today my topic, one of the important topic that I am going to discuss is about tree traversal. You all heard about ki tree is a what type of data structure? Tree is a, we have already studied, there are number of data structures that we have studied, linear and non-linear data structure, right? So we have studied linear data structure and non-linear data structure, right? Right, student? So under linear, already studied arrays, about linked list, about stack and queue data structure. These are the linear data structure, and non-linear is, number one is tree and number two is graph, right, students? So today I am going to discuss about how we are going to travel in a tree, in which manner we can travel, right? So before starting, we should know today I am going to discuss about tree traversal. There are three types of traversal. There are three ways in which we can travel in a tree: pre-order, in-order and post-order, right? So before proceeding, I must explain you what is a tree, what type of data structure it is a tree. So as we have already discussed, tree is a non-linear data structure. So what is the use of this tree data structure? We have already studied when the database is very big and a lot of information is there and we need to be efficient. And when we study this subject data structure, there are two important factors on which we focus, usually time and space. These are the two important factors, right? So keeping in mind, this tree data structure is very useful, very efficient. Whenever we want to discuss, whenever we want to search a long number of elements, a key from the long list, right? So to be efficient, we use a tree data structure, because we know that we will, whenever we discuss about tree, we will talk about binary tree, right? So how we define binary tree? So binary tree is defined as there are two things that we have to keep in mind. Binary tree is defined as a tree, such that tree is empty, either it is empty. For example, we have just initialized the pointer and we are just no element is inserted. Now we are going to insert the element. So we have the pointer is ready now, so such that the tree is empty, number one. If it is not empty, then there exists a root node, right? There exists a root node, and with respect to that root node, we have left subtree and right subtree. Some elements, some keys, some nodes we used to refer node. A term node is refer for that particular element where we keep it. There is left subtree and right subtree, right, students? So this is the definition of a binary tree. Now the question arises that how we are going to visit, in which manner. So you have already studied postfix and prefix expressions in the application of a stack, right? So what happened there in case of infix means, for example, this is an expression a plus b. So what is this plus? Plus is an operator. A and B are the operand, right? So operator lies in between two operands. This is an infix expression, right? When we write postfix, I can write this expression as postfix A, B plus. Operator will lies afterwards and operands are lies before the operator. And what about prefix? Plus AB. Operator lies before. In the same manner, you can remember this tree traversal also. Whenever the root comes in between, root node will comes in between left subtree and right subtree, then that type of traversal is called as in order traversal, right? Now the question is that, sir, this left node means left subtree. We have to visit this left subtree in the same manner. So the procedure is called recursively. Keep in mind, this is important, okay? The procedure is called recursively. Left subtree, in this left subtree, we will visit leftmost node, then the root node will giving the priority, then afterward we will give priority to the right subtree, okay? So in this manner we will travel when root lies in between. In this pre-order, pre means root will be preferred first. Root element will be printed first, then we will go to left subtree, then we will go to right subtree. Right, sorry, left and then right. And in post order, left, right, and then we will prefer root. Root will be printed at last in post order traversal, right? So you can remember this traversal. So in this postfix and prefix expression, I am considering this operator na. In place of this operator, I will place this root element. Okay, you just keep in mind. Okay, so let me discuss one by one, because we have to discuss the algorithms for these traversals. These are one of the very important topic from the exam point of view. Very important topic, this traversal. Okay, what happens in the examination? You are given with a tree and it is asked write pre-order, या in order, या post order of that given binary tree. Or there may be a case, a question is given, some order is given, in order is given with pre-order, or in order is given with post order, and you will asked to make a binary tree. These are the questions that are mostly asked in examination. Okay. At last, we will discuss about application of binary trees, where we will use practically from the Viva point of view. Okay. So now the tree traversal means we are going to process of visiting each node. Okay. We are going to visit, as I am saying that tree order walk, sorry, in order walk, pre order walk, post order walk. Walking means we are going to visit a node. Node means where the element is kept. That particular value that is kept referred as node in terms of tree. Okay. In a tree data structure, exactly once. Okay, we are going to visit only once that particular node. So tree traversal techniques are basically divided into two parts: a depth first traversal and breadth first traversal. Right, 1 and 2. Okay, depth first traversal, or we can say depth first search, DFS, and or we can say BFS, breadth first search. Okay, so this depth first traversal are further divided into these parts. So number 1, number 2, number 3, pre-order traversal, in-order traversal, and post-order traversal, that we are going to see in detail. Okay, breadth first search is just level wise level, because we know that when we make a tree, you know that a tree will consist of a root node. This is my root node, right? Why we call tree? When I used to say a tree na, so you must understood that I am talking about a binary tree. Binary means 2, 0 or 1, right? So there are two child, root element. At left we have a left subtree is there. This is called as left child. Okay, and this is called as right child. So in the tree definition, basically we will represent the representation of elements are in some hierarchical manner. Hierarchical relationship is there between those nodes. What does this hierarchical means? I can say this is a parent, this root node is a parent of these two child. These are the two child, left child and right child. Okay. I can also say that these two, the relationship between these two child, they are siblings. Okay. This is, for example, this is my left subtree, this is left subtree, this is right subtree, in which we have only two nodes, right? So every node, every element will have some relationship with each other. So the parent of this last node is this node, right? So these are called as internal nodes, right? These are called as internal nodes, and the nodes from which no node is coming out, right? That is called as leaf node. So these are the leaf nodes. The leaf nodes, or we can say it as an external node. These are some terminologies that you have to keep in mind. These are called as internal nodes. Okay. Now I want to show a relationship between this root node and this leaf node. So I can say that this leaf node is a successor of this root node. This is a predecessor. If I used to represent a relationship between these two, then I can say that this is predecessor, this is successor. Okay. Now if I want to show the relationship between these two, between these two. So the relationship is shown. I can say that this is grandparent, this is grandparent, and this is grandchild, right? So these are the relationships. The hierarchical relationship is there. Okay, so this hierarchical relationship is shown in terms of tree, right, students? So this is my 0th level, this is my first level, this is my second level, level wise level. I can divide it level. Okay, na? All the levels. Now total height, this will become the height of my tree. Okay. For example, at 0th level there is only one node. At first level there are 2 nodes. At this is the first level, this is second level, this is third level. At third level there is only one node, right? So when I represent level 1, number of nodes 1, now I will write here, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay. So when I visit nodes level wise, so on this level 1 will come. Okay. In this second level, which node will come first? Second node will come first. Now on first level, so this is the first level, right? We will start from a 0 index position. Okay. On this first level, we have 2 nodes. This is node number 2, this is node number 3. So then after 2, we will visit this third. Then next level will come. There are 2 nodes are there, 4, 5, then 6. So this type of visiting, level wise visiting, is called as breadth first search. Okay, students, this is very simple. Level wise, breadth first search. Okay. And under depth first, we are 3 options to visit a tree: pre-order, in order, and post order. Okay. So let me discuss. So depth first, this is pre-order walk, in order walk, and post order walk. These are the 3 traversal techniques. Okay. And the questions, definitely the question will come from any of these 3. Okay. So what happens in pre-order? That I have already explained. Pre means the priority is given to root node. Okay. So here it is written, we will travel number 1, we will visit the root. Okay. After visiting the root, we will go to travel the left subtree. Okay. How we are going to travel the left subtree? I have already told, it is done recursively. It is done recursively because it is compulsory that there is only one node. No, there exists a whole left subtree, and in that left subtree there are number of nodes. Okay. So we will call this, again we will call pre-order. See, this is a recursive function. The name of this algorithm is pre-order. Okay. And here we will left. This is the pre-order na, root, then left, then right. Okay, this pre-order. So when we will travel the left subtree, the left subtree will be follow this order, right? Left subtree. Okay, pre-order. Then the last we will give priority to the right subtree. Traverse the right subtree. That is again we are calling pre-order right subtree. Here we have left subtree, here we have right subtree. Okay, right, students? So pre-order means priority will be given to root first, right? Then priority is given to left subtree, then right subtree, left, right. Okay, this is how we will do traversal in pre-order. Okay, so now let us see the example. This is a given binary tree, and the question is that for this given binary tree, we have to write the pre-order. Now we know that while writing a pre-order, we have to keep in mind Firstly, we have to visit a root, then left, then right. Okay, students. So we will start traversing. Will be start from the root element, root node. Okay. So this is a root. Yes, this is a root, and priority is given to root. So the first element that will be printed is A. Right? A. Then we will proceed towards left subtree. When we proceed towards left subtree, then we have checked that this B node is a root of some nodes. Yes, it is a root. It means the second key, the node which will print is B. Then we will proceed again towards left of this. What is this? This is D. There is no element existing under this. No child was there. So this is the leftmost node. So after root, we will give priority to the left, and this left node is D. Then we will print D here. Then again we will backtrack. Okay, after backtracking, we will last priority is given to the right subtree. Then we proceed towards, this is the last root node that we have visited. Then we proceed towards left. Okay, from here we go to here, then here we will go to here. Okay, then we go to this, then right subtree, this is the right, under this left subtree, this is the right node. Priority, last priority is given to this. Then we will print E. Then again we will backtrack, right subtree. When we reach here towards right subtree, then we have seen that this C is a root element, root node. Then we will print C. Proceed towards left, priority will be given to left. Okay, priority is given to left. Then there is no left or right here. Then we will print this F. Then we will proceed towards G. Last element is G. This is the pre-order walk of this particular C. Right, students? Root, left, again we proceed towards left, but it is also root. Then priority is given to a root. We print B. Then we will proceed towards D. No child is there. This is the leftmost key. We have printed D. Then we go towards right subtree. Under this right subtree, this is the leaf node. No child is there. It means this is the last node that we have to visit under left subtree. We print E. Backtrack, go towards right subtree. When we proceed towards right subtree, we have seen that this C is a root node. Priority is given to root node. Then after E, we have printed C. Then we proceed towards left subtree. Under this left subtree, no child is there. This is the leftmost key. Under right subtree, then we have printed F. Then we proceed towards G. This is the rightmost key of this right subtree. We have printed at last G. So this is the pre-order traversal. Right? I think you will understand it. Okay. Now next is application. Applications is just for your awareness ki where we use this prefix. Okay. Pre-order traversal is used to get prefix expressions. Right? As I have told you, if we have given with in order infix expression is there, then what is the prefix expression of this? Plus AB, write this. It means that it is used to get a prefix expression of an expression tree for any expression tree. Now how this we can represent it in case of tree? Plus A and B. This is the tree for this expression, right? If I will walk, if I want to print a prefix of this binary tree, then we will proceed. How? This is a root element, we will print root, right? Then we will proceed towards left, then we will proceed towards right. See, am I right? So for the given expression tree, we will get prefix expression. So this is the first application, number one. Number two, pre-order traversal is used to create a copy of a tree. Definitely, we are creating a copy. If we have a pre-order, we can easily trace, we can easily write down we can easily create a binary tree. If we have a given pre-order with the in order, we can trace the binary tree. So it means that they used to create a copy of a tree, right? Now next, in order traversal. Simply, in order means infix. So infix means what is A plus B. operand, operator, operand. So here left, root, right. This you have to remember. Left, root, right. Okay. So we will traverse again in the same manner. It will call recursively. We will travel the left subtree in order, visit the root, then right subtree. Right. I think we can directly go to the example so that you can understand it. The same example is there. Now I have to write the in order walk. In order. In order means you have to give priority to the left subtree, a left child, then root, then right subtree or right node. Right. So we will start traversing from the root. This is the root. Priority will be given to left. Then we will proceed towards left, B. I have seen that this is a root again. There exists a left node. So this is the leftmost node of the left subtree. So we will print D first. We will print D. Right. After D, priority is given to root. We will print root, B. Then at last rightmost node of a left subtree, E. We will print E. Again backtrack. Now we will print a root because we have visited all the nodes in a left subtree. Then we will print A. Then we will proceed towards right. When we proceed towards right subtree, then we have seen that there exists a left node. Then we will print F here. Then root. At last we will give the priority to the right node. So this is G is the rightmost node of a right subtree. So in this manner, this is called in order traversal. I think now it is easy for you to understand. Okay. Should we move forward? Yes. Okay. So this is the application again. What is the application? In order traversal is used to get infix expression of an expression tree. Same. The application for the pre-order is used to get the prefix expression of an expression tree. Similarly, for in order, we will get infix expression of an expression tree. Right. Now the post order. Post order means A, B plus operand then operator. It means left, right, and the priority of the root is at last. See, left, right, root. Traverse the left subtree. Again, this post order call will be recursive. Right. Traverse the right subtree. Again, right subtree will in which fashion? We have to travel the right subtree in post order. Okay. Then at last visit the root. Okay. I think let us see the example directly. Now the same example. Now we have to write the post order. Okay. So for post order, left, right, and the root priorities at last. So we will start from here. Okay. Towards left subtree, priority is given to left. When we reach this, we come to know that there exists some left node. Then we will print this is the leftmost node of a left subtree. Then we will print D. After left, we will proceed towards right. E. At last, we will give priority to the root. Then we will print B. Root of these left and right. Okay. Then root. Lastly, we have to give the priority. So we have to proceed towards right subtree. When we reach here, we come to know there exists a left node. Right. We reach here. We will print F. Then right, G, C, then at last we will reach this A. So this is the post order walk, right students? Right. So priority is given in this fashion, left, right and root. Okay. So what are the application? Same application used to get the postfix expression of an expression tree. Post order traversal used to delete the tree. Yes, this is important. Whenever we want to use to delete the tree, we will use post order traversal. This is because it deletes the children first, because whenever we use postfix, it will delete the children, because the priority of this post order is we will prefer left node. So left node will be a child of a root node, right? Then secondly, we will prefer right node. Right node again is the right child of a root node. Then at last we will reach to root node, right? So it deletes the children first and then it deletes the parent. Okay, this root node is the parent, right, students? Now BFS is there's simple. This is called as level order traversal. I have already explained it. We are just going to print the nodes level wise level. Okay, for example 1, 2, 3, 4, like this, 5. So level wise level. This is first, second, third, fourth. 0th level, first level, second level, third level. So how we will print using BFS 1, 2, 3, 4, 5. This is level wise level. Okay, this is BFS. Tick. Level order. See, A, then comes B, C, then comes this level D, E, F, G. So the answer is A, B, C, D, E, F, G. Okay, 1, you can give the index number, 3, 4, 5, 6, 7. Okay, students. Now, for the purpose of your example, we have already discussed with the alphabets that node will contain key values and number will also 1, 2, 3, 4, 5, 6. So you can use this example to write the in order, pre order, post order, right? Now we directly go to a question. I have taken this question where in order is given, then pre order is given. Now the question is that trace a binary tree. Okay. Now how we are going to trace? This is important, very important. So in the question, in order is given, we have in order is given and we have pre order. Okay. Pre means root node is the priority. Pre, right? Pre means root, left, right. Okay. So first of all, we will check for the root element. Then we will see where this 25 lies here, right? So we will make step number 1 is we come to know about the root node. So 25 is a root node and the left subtree will contains 4, 10, 12, 15, 18, 22, 24. This is my left subtree and right subtree is 31, 35, 44, 50, 66, 70, 90. This is my right subtree. Okay? Now again from this left subtree I have to decide key which is the root node of from this given node. Then again I will see from these key, see 15 is there, pre-order 15. So this is the root node at this level and at 4, 10, 12 will lie in a left subtree, 18, 22, 24 lie in. This is my next step. Okay? First of all, we will just put the nodes in a left subtree. Then from the given 4, 10 and 12, see this 10. So 10 will be the root of this 4 and 12. And from here 18, 22, 24, 18, 22, see 4. Pre-order na, pre means root will be given the priority. So 18, 22 and 24. 18, 22 and 24. 22, not this. 22. So this is root node of these. Okay. Again, here we will check from this 31, 35, 44, 50, 66, 70, 90, which is the root. So we will see there here 50 from the given keys, right? 31, 35, 44 will come in left subtree, 66, 70, 90 will come in right subtree, right? Then again from 31, 35, 44, 31, 35, 44, this 35 is the root, 31, 44, and from here 66, 70, 90, 70. Na? So 70 is the root of these two child, 66 and 90. So this is the binary tree, how we can proceed a binary tree. Okay. In the same manner, when in order is given with post order, in order is given with post order, in post order we will prefer this root node. Okay. So when you will make a binary tree, you will get the same tree. Okay, students. So this is the important question, important numerical. So I think you will understand it. Okay, and try making a tree using in order and post order. You will get the same tree. Okay. Now, what is the application? Level order traversals application is to print the data in the same order. Okay. So properties: minimum number of nodes, binary tree of height h is equal to h plus 1, minimum number of nodes in a binary tree of height 2 to the power h plus 1 minus 1. This is the now third property. Total number of leaf nodes in a binary tree is total number of nodes with 2 children plus 1. Okay, these are the numerical values which you can calculate. Property 4 is maximum number of nodes at any level is 2 to the power l. We will 2 to the power l. We will come to know how many nodes are there. Maximum number of nodes can exist in a binary tree. Okay, so these are the applications for a binary tree. Okay, the most practical application is used in Microsoft Excel and spreadsheet. Okay, implementation of indexing of segmented database. Yes, we can make a split tree. Split tree is the binary tree, is a variant of binary tree which is more efficient. है ना, efficient cache in hardware and software system. Okay, binary space partitions we used to partition assign in algorithms in rendering game graphics. ठीक है ना, backface culling you can see. ठीक, syntax tree, yes, we have seen compute the arithmetic expressions in compilers like GCC compiler. This is the application. And binary heap used to implement priority queue, which is used in heap short algorithm. Okay, these are the applications that you can see. Okay, okay, I think I have done today. Okay, so thank you for today. Thank you, students.